and the presentation on a new report titled Controlling Emissions in Germany's Future Hydrogen Economy. My name is Andreas Goltau. I'm advisor at RIFS and professor at the Willy Brandt School of Public Policy at the University of Erfurt. We may give this another minute or two and to see who else might come along and join. So stay tuned. We're about to start shortly. All right. So good morning again. Welcome. My name is Andreas Goltau. I'm an advisor at RIFS and professor at the Willy Brandt School of Public Policy at the University of Erfurt. I have the great pleasure to moderate today's event. As you all know, hydrogen will be an important energy carrier that will help the world reach net zero, but it's also, and that's an often forgotten fact, it's also an indirect greenhouse gas. It could have significant impact on global warming if the emissions along the value chain are not kept in check. So we're talking about the necessity to come up with stringent policy measures, robust frameworks to deal with that issue. And I'm really, really glad we can discuss a new and very timely report today titled Controlling Emissions in Germany's Future Hydrogen Economy, published with the Research Institute for Sustainability, the Helmut Center Potsdam, and commissioned by the Environmental Defense Fund. Before I hand over to the lead authors of the report, that's Katie Marr and Rainer Quitzo, whom I will also introduce shortly in a couple of minutes, I would like to give the floor to first Mark Lawrence and then Helen Spence-Jackson. Mark Lawrence is the scientific director of the Research Institute for Sustainability, RIFS, and Helen Spence-Jackson is executive director Europe for the Environmental Defense Fund. Mark, the floor is all yours.
Well, thank you, Andreas, and good morning, everybody. It's a great pleasure to have the opportunity to welcome you to this webinar. It's great to continue the interaction with you, Andreas, that we've had very productively over these years, and thank you very much for moderating this. And I'd also like to say I really welcome the collaboration between RIFS and the Environmental Defense Fund. What I didn't tell Katie and Rainer is actually I have a history of relationship to the EDF that goes back way far back, long before I was here at RIFS. Namely my former thesis advisor. I had two thesis advisors. One of them was Bill Shamides from the Georgia Institute of Technology. And after I finished my thesis, he went off in 2005 to be the chief scientist of EDF for 3 years. And that flavored some of our early interactions with EDF once I started at RIFS in 2011, and have appreciated the interactions in various fronts ever since then. I'd also just mention briefly my other thesis advisor was Paul Crutzen, and today would have been his 91st birthday. And Paul was quite influential in many ways, and his name will actually come up in a few minutes as I get to the end of this brief introduction. He was also a great supporter of RIFS. RIFS, the Research Institute for Sustainability, has been in development since about 15 years. It was originally founded as the Institute for Advanced Sustainability Studies, a much more difficult name, the IASS, by our founding director, Klaus Töpfer, who had been charged with putting together an institute that would have a different form, or would develop a different form of interaction than the traditional science policy and science-society interfaces. And we have been working on this path since then. I've had the fortune of being here since 2011, and we've built up a tremendous team of people from all sorts of different topics. And it's great when we have activities like this, which bring our work on various topics, such as on the energy transition and on air pollution and on climate change, all together within one project. Hydrogen. Hydrogen is a wonderful topic to have as a central issue, and hydrogen is a marvelous substance. It's the simplest atom, it's the smallest, lightest molecule, and it's a magical component of H2O, of water, even though it's only 10% of its weight by molecule. Hydrogen is versatile and powerful in all sorts of ways. It's very light, of course, which makes it useful for buoyant aircraft, but it's also explosive, as we've well known since the catastrophic Hindenburg explosion, which showed some of the challenges in using hydrogen for buoyant aircraft. And as Andreas already mentioned, it has very important indirect environmental impacts, which may be potentially significant in the future. And of course, hydrogen has a substantial potential for being important for our energy systems. As you all very well know, hydrogen is not an energy source, it's an energy carrier. We know that here, but it's also important to know that that's widely misunderstood. And it's very important that we communicate that well, that hydrogen is a transfer mechanism for energy, but where many people mistakenly think of it as directly a source. Hydrogen has an immense potential to support our systems transformations, especially in the mobility systems. And we've done a number of studies here at RIFS, and there have been studies around the world at how hydrogen could contribute to transforming the mobility system. But it can also be important in other industrial systems. At the same time, it's important to see the challenges that we face with hydrogen. And these are on two major fronts. One of those is the production of hydrogen. And the report and other work that the report has looked into shows that the hydrogen production might not be so beneficial, especially if blue hydrogen is associated with methane leaks. And we know, of course, the incredible potential that methane has, the very large global warming potential that methane has, and the capacity that it has to warm the environment, which is already at a level of roughly a fourth of the warming from carbon dioxide. So we have a very important aspect of hydrogen production to watch into and make sure that the production is not actually undoing the benefits that we get from using hydrogen in our energy systems and our mobility systems. At the same time, hydrogen itself has a direct influence on atmospheric chemistry. In particular, hydrogen reacts with the little OH molecule. So it's water minus one hydrogen. And when hydrogen reacts with the OH molecule, it's a very well understood reaction that we have in the atmosphere. We know very precisely what the reaction rate is. We know what the products are. We know how this then in turns influences the methane lifetime and other aspects of atmospheric chemistry, since the OH radical is a very central component of atmospheric chemistry. There are some uncertainties. There is uncertainties in the scenarios, in the amount of hydrogen leakage and the venting and the emissions that we'd be expecting. But once the hydrogen concentration is known, we do have a high degree of certainty regarding its impact on chemistry and climate. It's one of the things that I'd say we know best. And in fact, the knowledge of that goes all the way back to the 1970s, the early 1970s, when groundbreaking work was done to understand atmospheric chemistry by the two people that I mentioned before, by Bill Shamides, former chief scientist of EDF, and Paul Crutzen, Nobel laureate in atmospheric chemistry, or Nobel laureate in chemistry for his atmospheric chemistry work, and many, many others who contributed to that understanding. So last thing is that this understanding has developed so much further, and in 2023, a study was done that showed that the 100-year greenhouse warming potential or global warming potential of hydrogen can be characterized indirectly to be about 12. That's quite significant when you compare it to the global warming potential of methane, which is slightly under 30 on a 100-year timescale. So that all leads us to the implication. If we really want to benefit from hydrogen, we need appropriate technologies, policies, and corporate cooperation in order to limit the environmental impacts of hydrogen, as pointed out in the studies, and as I'm sure will be delved into in this webinar. So I hope you'll all enjoy the webinar. I'm looking forward to enjoying the opening of it. Sadly, duty calls for me, and I'll have to leave at about 10:30, but I wish you all a great time and good discussions together. Thanks, and back to you, Andreas.
Thank you, Mark, for your kind words of introduction. Can I hand over to Alan Spence-Jackson of the EDF?
Thank you, and indeed, good morning, everybody. Thank you for the introduction, and thanks to RIFS for this really comprehensive report and the accompanying policy recommendations, and indeed all your work in this space. As just has been alluded to there, it is absolutely critical that we get hydrogen right if we're going to see the expected climate benefits from this emerging economy in Germany and in Europe as a whole. And for the EU to be able to achieve its mandate of this 70% of emissions savings from hydrogen compared to today's fossil energy, we need to absolutely be clear-headed about the true climate impact of hydrogen systems and indeed ensure that those effective policies are in place at national and EU level to be able to control all the related climate warming emissions. And that includes indeed not only CO2, but also methane and hydrogen. Mark just explained some of the science behind the work. And from a policy point of view, we have to absolutely remember that hydrogen and methane both have got potent impacts on our climate, especially in the short term, which when we're thinking about this from the policy perspective about the next crucial 20-year window, it's going to be greatly influenced by the extent to which we're able to limit these emissions of all these various gases. Now, Environmental Defence Fund there, as a leading global science-based advocacy organisation, we have a mission to stabilise the climate. And we've been working very much on this sense of making the invisible visible. Working very closely with the current chief scientist, Steve Hamburg, we launched last year our very own methane sat, a satellite that's providing the data for us on methane emissions. And we have similar ambition for hydrogen too. In collaboration with industry, we're starting to measure hydrogen emissions from existing facilities with a first of its kind high precision sensor. And this is all with the goal of helping maximize the climate benefits of hydrogen systems. And here in Brussels and across our team in Europe, we're collaborating with policymakers, with industry, with investors, and the science and nonprofit community to help Europe reach its climate goals. So I'm absolutely thrilled to see so many of you on this webinar to discuss the findings of the report and how the recommendations can lead to more effective solutions for hydrogen to do this. And so with no further ado, back over to you. Thank you.
Well, thank you, Helen, and also for stressing the important work that's being done at the Environmental Defence Fund. And with that, we switch over to our lead authors who led the report. And let me also maybe stress that both of them epitomize essentially what RIFS stands for, which is a truly interdisciplinary approach to the problems we're facing when it comes to sustainability, climate, and the environment. Katie Marr leads the research group Climate Action in National and International Processes. She specializes in atmospheric chemistry. And Rainer Kvitzow, the second lead author, is the leader of the research group Geopolitics of Energy and Industrial Transformation. He has an honorary chair at Technical University in Berlin, which focuses on sustainability and innovation. With that, I would very much like to hand over to Katie and Rainer to walk us through the important findings of the report and what follows from it for policy and regulation. Katie, Rainer, the floor is all yours.
Thank you, Andreas, and thank you, Mark and Helen, for the words of introduction. So you've made the first part easy. As Andreas said, I am Katie Marr, and I'm going to start here with an overview of what we did in our study and accompanying policy brief. So just in case you haven't seen it, these are the covers of our publications. So the one on the left, Controlling Emissions in Germany's Future Hydrogen Economy. This is a longer form study where we developed some scenarios and did calculations to look at the climate impact, namely the global warming potential of emissions from a hydrogen economy. So I'm going to present a brief overview and some highlights of the results. And then we have an accompanying policy brief on the right. So I'm going to present some intro and results and hand over to Rainer afterwards to discuss our recommendations and present them. So here, I don't think I actually need to say much more. We know now and we've heard, okay, hydrogen is poised to become big. We already use, of course, some hydrogen, but there are lots of ideas and also concrete plans about how hydrogen is going to help us decarbonize our economies and help us get to net zero greenhouse gases. It's also really seen for certain industries, especially heavy industries like steel or also the chemical industries. In these cases, it's often seen as really the only option to decarbonize. But as we have already heard here, like in our study, we asked the question, okay, what about emissions along the hydrogen value chain? How do we make sure that we do hydrogen well, and yeah, with environmental integrity? So, okay, what do I mean by the hydrogen value chain? So what we looked at in our study were production of hydrogen as well as conversion, transport, and storage. And if we stay on the left for a minute, we consider two types of hydrogen production. The first is green hydrogen, which means we're producing hydrogen from electrolysis with renewable energy. And there, we're not producing CO2, but we still need to consider the emissions of molecular hydrogen, of H2, and then what impact they might have. If we look at the bottom left, we also consider blue hydrogen. Blue hydrogen is fossil-based, so with methane as a raw material. And so we have methane emissions coming from blue hydrogen. We also have the hydrogen emissions we still need to care about, and also CO2 emissions, even though the definition of blue hydrogen includes carbon capture and storage, we know that that's not 100% perfect. And so looking at these steps in the value chain, what we did in our study was take emission factors from the literature. So we have applied, basically based on best available knowledge. Now we looked at kind of low emission rates and high emission rates, and applied that in our calculations. Another thing we do is compare these calculations based on emission rates that we expect to the assumption that the EU low carbon threshold would be met. This is equivalent to a maximum emissions intensity of 3.38 kilograms CO2 equivalent per kilogram of hydrogen produced. And Mark already introduced the global warming potential of hydrogen. We take 11.6 from this recent study in 2023. And here, just to say one more time, hydrogen is an indirect greenhouse gas because its chemical reactions in the atmosphere lead to increases in methane, also increases in ozone and stratospheric water vapor, all of which have a warming impact on the atmosphere. Okay. And so continue on what we did in our study. We did a case study specifically for Germany in 2045. And why did we do that? Well, for one thing, RIFS is based in Germany. It's relevant for us, but Germany also has very concrete plans and policy documents that we could use as a starting point. So Germany has a national hydrogen strategy. And Germany also has a 2045 goal to be net zero greenhouse gases. So if we first look here and ask the question, okay, how much hydrogen do we expect Germany to need in 2045? We have two different cases here taken from German policy documents. Here it's these Langfrist scenarios, so long-term scenarios that get us to a climate neutral 2045. And so we have two different cases here, one with high hydrogen demand and one with somewhat lower hydrogen demand, but more direct electrification. Of course, this low hydrogen demand in 2045 is still high compared to what we have today. Oops. Just want to go back. A couple other points to mention about the assumptions made in our scenarios. One is that we assume that domestic, meaning German hydrogen production, will be 100% green with electrolysis, and that's in line with German plans and policies. But Germany also expects that it will need to import significant amounts of hydrogen, maybe up to 2/3 of its demand. And in our calculations, we use different assumptions. We have some scenarios which assume that all hydrogen is green, all imports and all domestic production. We also have some scenarios that assume that some of the imported hydrogen will be blue hydrogen of origin. So a very quick tour of the results. First, I want to start with our scenario that considers only green hydrogen. So Germany in 2045 is meeting its hydrogen demand by 100% green hydrogen, some domestic, some imported. And how much do we have in hydrogen emissions? Well, we calculate that we have 11 megatons of CO2 equivalent and hydrogen emissions. And is that a lot? That's equivalent to 17% of Germany's planned residual emissions in 2045. I want to take a moment here just to repeat this context because it can be a little confusing. So our calculations are for the Germany in 2045. In 2045, Germany has a plan and a goal to be net zero greenhouse gases. What does that mean? Germany is already planning, Germany is not saying that it's going to get to zero emissions in 2045, rather that it will have 63 megatons of CO2 equivalent in residual emissions that they haven't managed to eliminate, but then to get to net zero, this will be compensated for by an equivalent amount of carbon dioxide removal. So that's where we are in 2045. And these hydrogen emissions of H2, are not accounted for in this accounting. I think Rainer will speak to that, but it's almost never the case. But so we're saying, okay, how much hydrogen are we emitting potentially? Up to 17% of the planned residual emissions. That's really not nothing. It's significant. We have to take that into account. Another thing I want to point out here is that based on our calculations, the most important source of hydrogen emissions is production. So we have these larger purple parts of the chart. Most of these emissions are coming from the production of hydrogen using electrolysis. And why is that? Under current practices, there are some steps within the electrolysis where emissions or where gases are purposefully vented, purposely released to the atmosphere. These are usually mixes of gases, but include hydrogen. And this is for safety and process reasons. But this means that we're getting potentially significant amounts of hydrogen produced here. The good news is if we assume low emission rates, which in this case in production translates to different practices where these emissions are captured and recombined to produce water, then we can reduce those significantly. So a final slide on results here before I pass on to Rainer. This slide is a little dense, but what we're showing here is what happens if we also consider blue hydrogen in the mix. So in the past couple of slides, I was really considering only hydrogen from electrolysis and only H2 emissions. But if we are also considering that some of Germany's hydrogen need will be met by imported blue hydrogen, we see that the impact, the global warming impact, so this total megatons of CO2 equivalent goes way up. And that's even if we consider that this low carbon standard is met. So this middle bar shows how much greenhouse gases we get if we include 1/3 blue carbon imports in the mix. And then on the right, we see what happens to the emissions if we assume high emission rates from blue hydrogen. So the point here is that if we include blue hydrogen, the emissions jump way up, and those are, of course, dominated by methane and CO2 emissions. If we look at this right-hand column where we see the most emissions, these emissions are dominated by current practices. One of, we know that in methane production and transport, we have a lot of leakages built in. And the other thing is we're not doing, we're only achieving really 60% carbon capture in our CCS. Maybe there's a chance to go into these numbers in more detail if there's interest. But for now, I would pass on to Rainer Quitzow, who's going to transition into what this means for policy recommendations. So, Rainer, over to you.
Thank you very much, Katie. So I'll take over here and you can just jump over to the next slide. So in the second part of the report, we first look at what the existing hydrogen policy landscape looks like, which is especially the EU level. Of course, there's also some relevant legislation in Germany itself, but a lot of it is being regulated at the EU level. So we also focus a bit more on policy implications for the EU level, but not entirely. Here you see a graph of some of the different regulations that are already in place and to what extent they touch on production, conversion, and transport or storage, or all of them, and also what emissions, what types of emissions are actually regulated by these different policies. And what we can see is that hydrogen emissions are not very present in this regulatory landscape. I mean, there are places where hydrogen emissions are touched upon in the regulatory landscape, but they're overall it's more focused on CO2 and to a certain extent also methane. There is one piece of legislation, the Hydrogen and Decarbonized Gas Market Package, that does also address hydrogen emissions along the hydrogen value chain. It also introduces this low carbon threshold, this low carbon hydrogen standard, and which requires a methodology for calculating the greenhouse gas savings from low carbon hydrogen. And this methodology is currently pending review. There's a draft out there. There's been a consultation around it, and there's a discrepancy here between what is actually detailed in the package itself and this methodology, which is an additional piece of legislation to support that package, in that it actually doesn't include hydrogen as a greenhouse gas currently for calculating the greenhouse gas savings. So this is sort of just an intro into the hydrogen policy landscape and where we stand in terms of hydrogen emissions. We can move to the next slide, where I'll now jump into our main recommendations, where we found places where we found we could take action relatively easily to tackle these challenges that were described by Katie. So a very easy sort of way to address this is to define maximum emissions rates for electrolyzers. As we heard, production of hydrogen, the electrolysis of hydrogen is one place where we could potentially have a lot of emissions, but it's also a place where it's relatively easy to reduce those emissions. So the good news is if we take action, we can really bring those hydrogen emissions way down, which would mean that we can secure its contribution to decarbonizing the sectors where we really need hydrogen. And this can be done immediately or rapidly through national pollution control legislation. So Germany, for example, could introduce such maximum emissions rates in its national pollution control legislation. And then at a later stage, this could then also be introduced at the EU level in the Industrial Emissions Directive, which would then also enable a process of diffusion if other member states haven't adopted similar measures that at the national level. And then we also recommend that we simply develop more knowledge, more understanding of where emissions are occurring, what levels they actually have, because we had to work with a lot of sort of estimates and assumptions, but of course it's important to get the real measures and the real information. So another recommendation we make is to mandate the European Environment Agency to start a systematic monitoring of H2 emissions along the value chain, so we get a better grasp of that. And then, of course, we also recommend, I already alluded to this, to include hydrogen emissions in the methodologies for calculating greenhouse gas savings from the low carbon hydrogen for the low carbon hydrogen in the hydrogen and the gas and hydrogen package that I mentioned before, but also then for so-called RFNBOs, renewable fuels of non-biological origin, which includes hydrogen, green hydrogen. This also is subject to a greenhouse gas threshold, and it also does not yet include hydrogen, and this could be updated when another review of this methodology is conducted. So this is, next slide, please. So now coming to blue hydrogen, as we heard, has the potential to have far more, impact on the climate, of course, than green hydrogen. We know this. So for this to be, to ensure that we tackle these emissions and make sure that they're under control, we recommend to ensure very high levels of transparency and robust certification schemes to verify compliance with greenhouse gas savings thresholds for low carbon hydrogen, for imported blue hydrogen, because mainly we would expect blue hydrogen to be imported. And this means that we also need to work with our partners from those importing countries, or exporting countries rather, to make sure that when we require compliance with these greenhouse gas savings, that we actually maintain those emissions thresholds that we promise. We also would recommend increasing the stringency of this greenhouse gas savings threshold over time to make sure that we bring greenhouse gas savings, or improve greenhouse gas savings over time, as we also gain experience with these technologies and we establish these robust certification schemes, so we can also verify this. And then finally, one more immediate place that also could allow us to really tackle this is the EU methane regulation, which has just recently come into force and covers methane emissions in the EU in general, but also for certain fossil fuel products that are imported into the EU. It doesn't include imported hydrogen or hydrogen derivatives. And this could be another place that we could expand this particular piece of legislation, because essentially we're referring to the same upstream supply chain, the upstream natural gas supply chain in these exporting countries, which would be covered when importing the gas, but not when importing the hydrogen, which would be produced from that gas. And now the final slide, please. So, and the final sort of area that requires work in our view is to really raise awareness of this role that hydrogen plays as an indirect greenhouse gas. So we would support, campaigns to raise awareness of hydrogen's role in that sense, without discrediting its important contribution to decarbonizing hard to abate sectors, because we do believe and we think that we know that hydrogen is essential for decarbonizing sectors like steel and chemicals. So we can't, we will need hydrogen for this, but we need to also deal with the emissions. And one place to do so is in the next IPCC assessment report, and we recommend updating the global warming potential for 100 years for hydrogen in that assessment report, and that's something that we could support also as a German government, as the European Commission. So with that, thanks to the audience and for listening, and now I'm very curious to hear what our discussants have prepared.
Well, thank you, Katie and Rainer, for walking us through the main findings of the report. And I don't want to repeat what has been said, but I think it became absolutely clear that policy choices matter. I mean, it very much depends on what you do, whether you go for green or blue, or a mix of both, and that gets us to very, very different numbers. And thank you for pointing that out. Plus, as well, also, it obviously is important to think about the various levels of intervention, national, EU level, and how these are intertwined to address the problem, and you drove that home. So thank you very much for that. I see a couple of questions already in the chat, but before we get to any of those, and we will, let me also maybe right now turn over to our discussants. We're fortunate to get some reactions from, well, let's call them policy world, from 3 individuals, and let me quickly introduce them. We would start with Ricarda Dubbert, who's a senior expert on energy and climate protection at the Environmental Action Germany, Deutsche Umwelthilfe. We would then hand over to Christine Falken-Großer, Head of Division Director Hydrogen Coordination at the Federal Ministry for Economic Affairs and Climate Action. And finally, bring in Robert Spannheimer. He's an expert on climate neutral gases and supply security at BDEW, the German Association for Energy and Water Industries. So thanks to the 3 of you already for joining today. Can I just hand over to Ricarda and give you a couple of minutes for your quick reactions. Thank you.
Thank you, Rainer and Katie, for this study and the policy brief. They are very useful in shedding light on this new energy carrier, especially the comparison between emissions from green and blue hydrogen are very clarifying. I remember 5 years ago when the economics ministry adopted the German gas strategy, the word methane was not mentioned once in that document. If you typed Control F methane, you had no results, meaning that there was no political or public awareness for methane emissions and their climate impact. And the same goes for hydrogen emissions as well today. We have thankfully come a long way. The same ministry is implementing the EU methane regulation now. That's great progress. With the ramp up of hydrogen, we have a window of opportunity, but also a duty to address its emissions properly from the start. We do not want to introduce a new energy carrier and leave the emissions from it unabated for decades. In that sense, we have to learn from the mistakes we made with fossil gas. The recommendations from the policy brief presented just now are essential. The regulation, monitoring, certification, the strict thresholds, very good recommendations. We also need an information campaign raising awareness on hydrogen emissions. Because as you said, Rainer, the current public debate, newspaper articles, they never mention hydrogen emissions. It's not present at all in the debate. And we need to fill this void with information and facts. We do not only need an information campaign on hydrogen emissions, but also on hydrogen in general. There is a huge gap between the hydrogen fantasy and the hydrogen reality. And the best way to limit hydrogen emissions, and the study mentioned this right at the beginning, I loved that part. The best way to limit hydrogen emissions is to limit hydrogen use. And we need to talk about this more. We all remember the saying, the best kilowatt hour is the one saved. Yeah, this goes for hydrogen as well. And we need more political steering as well. While hydrogen projects are being cancelled before final investment decision, German gas suppliers, utility companies, are literally sending out letters to their gas customers praising the advantages of installing hydrogen-ready gas boilers. And this is happening in Germany now. And this does not add up, fantasy and reality. For that, we need more steering, more information, and less fake hope. It is a missed opportunity, and I'm sorry I have to mention this, but it is a missed opportunity, if not a failure, to not exclude hydrogen from heating when the German Building Energy Act was adopted last year. What a waste of resources, for example, personnel resources at municipalities who are already struggling financially and who have to carry the largest load of the transition, to check for hydrogen suitability in their heat planning. What a waste of resources that our regulator, the Bundesnetzagentur, has to set up new regulation only to accommodate that massive exemption from the 65% renewable heating target. This all draws resources away from more efficient technologies, electrification solutions that exist now, that are in the market, that are not being researched and developed, but that are developed full stop, that are available and create value and truly lower GHG emissions. This might sound like I'm getting off topic here, from today's actual question on hydrogen emissions. But to be honest, I think we have to zoom out to see the big picture. And I think we do that too rarely. Hydrogen is not an end to itself, but it's a means to reach climate neutrality. And if the hydrogen economy does not fit this purpose, then we need to question hydrogen use itself. Just some food for thought. Thank you very much.
Thanks, Ricarda. Christine, I guess a few points were addressed or pointed a little bit towards your direction here. So can I suggest you take the floor?
Thank you very much. And thank you very much for having me. Lots of points were addressed that I would like to get into, but we don't have time for all the details, especially in the heating discussion has been addressed before. I would like to focus on the study and on the results there, maybe. We're very grateful for the work that you've done with the study and also in advance. We've been following this discussion also with EDF already since 1 or 2 years or 3 years since it's been out and being in the public, also at COP and other forums. So we are well aware of what is happening, and we are also well aware of the facts that are out there already that being researched. It's good to have more data out there now. It's good to have more information out there now. However, we believe that this is a market, the hydrogen market, that is still very much in development. If that is not even an exaggeration already. So we're in a very, very start. So the data that you use, especially for like carbon capture rates or similar, are current state of play, but we do expect a lot of things are happening there with a new scale and different technologies that are being developed right now, as it's normal for a market that is being emergent. We do want to be careful and very conscious and very clear in the tracking of emissions. We do want to have a very transparent solution and view on what is happening in the market. However, we do have a market that is right now struggling to build up. And while there are voices that rather have no hydrogen use or less hydrogen use, we believe that as long as we don't have any alternative for certain sectors, and we don't have any alternatives for certain sectors, as long as we don't have them, we have to find a way to develop the use of hydrogen into a sustainable possibility of decarbonizing the sectors that we can't decarbonize otherwise. Also to state this very clear, because this might not be very present with everybody, the BMW UK, with the predecessors as well, but especially, of course, under our Minister Habeck, is very clear that electrification is first choice wherever possible. It's cheaper, it's more efficient, we all know this. However, there are sectors, and it's not exactly the mobility sector and definitely not the heating sector I'm referring to, but there are other sectors that have a very hard time to decarbonize, if not with hydrogen. Rainer pointed it out very clearly that we do have the challenge of these two goals. On the one hand, have the transparency in the emissions, but on the other hand, also enable the market to develop solutions, first on technological base, but also within the market sphere to have scaled products that we can actually use. And this brings me now to my last point, and I'm very serious with this, with having said everything of acknowledging of what we want to achieve. But we do have a market that is on the tip of falling into something that is not going to work out right now. Everything we do in the ministry right now is really to wreck our brains hard and how we can enable, especially green hydrogen, to be less costly and to bring down prices and costs with scale, with better technology, with whatever. It's a really tough job. It's basically impossible. Whatever we do, we have to be very aware that we want to have this alternative as a real alternative to fossil emissions. So what I wished for in the study is also that you maybe show what is the fossil alternative emissions and how much better or how much worse it would be to actually use green hydrogen. So for example, in the study, if you use the steel sector and you go for the CO2 emissions of the steel sector that is using right now with coal and gas, what would be the alternative if you used hydrogen? What is the alternative, like really measured with the H2 emissions? So I'm left questioning, is it better or worse to use hydrogen in the steel sector or not? When I read your study or the result or the summary, I get the feeling that maybe we shouldn't go for hydrogen at all. Maybe we should just leave it all to coal and gas also in the steel industry. So to have more clear answers to, is perfect the enemy of the better, or is it still better? And is it still better to have a hydrogen solution and to develop this into something more sustainable? So these are the questions, and I just want to warn a little bit, a word of warning out there. We have a market here that is very nascent, that wants to develop, and we want to develop it into the right direction. And messages that come out here right now are being taken very sensitively. So we have to be aware of our responsibility also in the sense of climate and climate neutrality in these sectors that we need solutions for. Thank you.
Thank you very much. And let's bring in Robert here. The floor is yours.
Yeah, also thanks for having me. And I think it's been really important. What we heard is that hydrogen is the option that we have in the hard to abate sectors. And what we need now is to develop the market for hydrogen and to have a ramp up of the hydrogen economy. And this is, I think, really important not to forget about the situation that we are in now. But I think we have a common ground. Remembering all what we heard now is the awareness for that we need to abate and to avoid hydrogen emissions. That's where we as the industry can easily agree on. It's already my task at BDAW is to manage our working group on methane and hydrogen emissions. So we already concentrate on hydrogen emissions, and we work with our membership to raise this awareness. And it's something the industry is already working on for years. For example, there is a hydrogen testing field in Bitterfeld where grid operators for 5 to 6 years are testing H2 readiness of all the grid elements and also end-use appliances. I think you were in touch also with the research that has been done there. What you showed in the study, for example, concerning electrolysis, that there that we need to have a low emission standard there. That's what we can easily agree on. It's also for new appliances already the standard to avoid venting hydrogen from electrolyzers. The same is also for transport, to catch the boil-off, for example, for liquid hydrogen when in track transport. This is something that needs to be done and that can be done. So I'm actually pretty grateful that you pointed this out in your study, that there are technical solutions, and especially when it comes to green hydrogen, we can cope with this challenge. It's not impossible to avoid most of the hydrogen emissions that in this early technological stage are there. And I'm also grateful that you pointed out that concerning blue hydrogen, there is quite a lot of regulation already in place coming from the methane regulation and import requirements that are building up now, and that are also linked to the regulation for low carbon hydrogen. I think it's important that we move forward. The Commission is working on those standards for imports and establishing also the European standards at production sites outside of the European Union. I think if we go forward on that path, even for blue hydrogen, we will find out that it can play its crucial role in ramping up the sector. And yeah, that's maybe one last thought. Comparing to natural gas, there's one more important difference between hydrogen and natural gas in practice. Venting hydrogen is definitely a problem just as much as it is for methane. But in practice and in maintenance practice, for example, it's really a lot easier with hydrogen because you can flare it without having an environmental impact. So I'm pretty optimistic that we can tackle this problem. Thank you very much.
Excellent. Thank you very much. Now, I'd like to invite Katie and Rainer to reflect a little bit on points that have been raised to the extent that they would like to. But before they come in, can I maybe just highlight 3 questions that have been asked by the audience and which speak a little bit to the themes that have been touched on already. So maybe you can, in your answers, you can maybe bear in mind those questions and try and address them to the extent that you'd like to. The first question that comes in here is essentially a question related to the methodology and the extent to which it ties into the German scenarios, the Langfrist scenario you talked about. The question here is essentially to what extent are the emissions, the report calculated in addition to the ones that have been outlined in the scenario? So are they on top? And or is it are those included? I guess maybe that's a good point to clarify. The second point that has been raised by one of the people in the audience is whether production, conversion, transport, and storage contribute differently to emissions, and whether there's any room for prioritizing when it comes to solutions. I mean, you talked about production, but there's obviously more, and I think that would be an important point to address. And maybe as a final one, what do you do? I mean, at the moment, 1% of hydrogen production, that's the estimate by one of the members in the audience, is currently green. So how do you get this to 100%? How do you ramp it up? What is it that follows for policy action? Katie, Rainer, the floor is yours. We have another 8 minutes or so. You divide up the time as you wish.
Katie, if I can go first, if you like. Okay, I'll go first. So I would like to react both to the discussions, but also to the questions that were asked. Maybe first the point on timing. I think, Christina raised that point, and also Robert, that we need to first ramp up hydrogen. We're not in the luxurious position to already have a flourishing hydrogen economy that is decarbonizing hard to abate sectors. So yeah, absolutely, and I fully agree. We need to accelerate the ramp up, and that should be a major focus. At the same time, I think it's important to raise these issues early on, to give companies, to give the sector the chance to really be aware of this as we develop the new solutions. So I think it is important to raise these things early on, but of course, then it's a matter of also discussion and dialogue, I think, between policy, science, and industry to find the right way forward to ultimately mitigate greenhouse gases where they occur and find a way forward to balance the different priorities. I really liked also Christina's comment on the fossil fuel alternatives. That's a very good comment, and I think I might take her up on that. Maybe we can write a blog or something similar to really also point out that we're clear, of course, that coal-based steel production is not the future. The future is a decarbonized steel production with hydrogen, also with scrap-based electric steel production, of course, but we're not talking about going back to coal here. And then just more generally, and I've already touched on it, I think the way forward for all of this to find the right solutions really is about cooperation and dialogue. And I think that's also the spirit in which we understand this study, we understand this webinar, and the discussions we're having is to really get together, put our heads together, and find the right solutions to really get to net zero. And that brings me to the question on methodology. The long-term scenarios, the Langfrist scenarien, are net zero scenarios for 2045 for Germany. They're not necessarily government policy in the sense that we have policies in place to really get there at this stage, but it's where we want to go, and it sketches out pathways to getting there. right? And there we also have those residual emissions. Those residual emissions do not include hydrogen emissions. They're not accounted in that. But we also have to understand when we talk about hydrogen and hydrogen imports, hydrogen emissions, for example, or emissions from blue hydrogen that's imported are not part of Germany's residual emissions either. They would be part of the emissions in those countries where they are produced. But it's just to put in perspective, the volume or the size of the carbon footprint that hydrogen, blue, green hydrogen would have. But not all of that would actually be accounted for within the German greenhouse gas accounting because part of it would be imported emissions. Point on production or on the value chain and where the emissions might occur, we identified from the literature that production is the place where most of the emissions would be occurring in the production of green hydrogen. And as Robert also pointed out, it's a space where this can also be mitigated relatively easily. So I think the big priority should be to really work on that. And of course, not neglect the other parts either. And finally, how do we get to this flourishing green hydrogen economy? Well, it's the classic chicken and egg problem. We've been spending quite a bit of attention on figuring out how to ramp up hydrogen supply, but I think at this point it's clear that we will need the downstream demand side support as well to really get those end-use sectors going that require hydrogen to allow them to produce their green alternatives to the current fossil fuel production pathways. And in my view, this is really where we need to focus attention going forward, is to really find a way to catalyze investment at that stage so that we can get the demand and the offtake for the green hydrogen supply. And I hope I didn't take too much space. Katie, maybe you can wrap up by adding some points from your end.
Yeah, I think Rainer covered quite a lot already. Thanks also from my side to all of our discussants for your words and critique and feedback. Maybe just a couple of points to add on to what Rainer said. In terms of the question is, okay, are the emissions that we calculated on top? Rainer also already said, yes, they're on top. But just to mention again, so the recommendation that Rainer presented about raising awareness of hydrogen emissions, it gets to the fact that so hydrogen itself is not a direct greenhouse gas. So it's not part of climate accounting right now. So when countries are doing their submissions to the UNFCCC, when they're doing emissions accounting, hydrogen is not part of that. At current levels of hydrogen use, probably it can be neglected, but we're saying, okay, if we ramp up hydrogen, we need to consider this because, we don't want to get to net zero just for the sake of getting to net zero so that it doesn't, make sure we do the math so that we get to net zero at the end. We want to get to net zero because we want to reduce our impact on the climate, to bring that as small as possible. And we know that hydrogen does have this indirect greenhouse gas effect, so it does have an impact on the climate. So going forward, we need to start to be cognizant of that and think about where it needs to go into our calculations about how much are we impacting on the climate. Regarding prioritizing solutions, Rainer also mentioned what we stress in our studies. We find, okay, that the first place to prioritize is really emissions from production. But I think another important thing will be as we go forward with increased monitoring capabilities for hydrogen as well as other emissions. That's one of the things that can guide us as we get more and more information. Are there other sources of leaks, let's say, that we didn't anticipate? Are we doing well there? So I think that's also going to be important in steering our priorities. I think that's what I had to add right now. So I'll pass back to you, Andreas.
Well, thank you. And thanks everyone for joining in today. We're at the end of our webinar. I guess there's two things I'd like to say. First of all, thank you very much to Helen and Mark for the kind words of introduction. A great thanks to Ricarda, Christine, and Robert for their comments and their input. And obviously a great thanks to Katie and Rainer for presenting the important work they have done. on emissions from hydrogen, how to keep it in check. I think, what the report and the presentation drove home, in fact, is, and I alluded to this in the very beginning, how important it is to actually break down silos between different disciplines to get to results that are tangible and give us evidence that we can build policy on. And I'm very grateful for the piece of work you did. Follow the work on hydrogen that is being done at the moment at RIFS. You saw a glimpse of it today. There's a lot more. And it's very important work. It's work that extends beyond emissions control and goes all the way down to asking how does hydrogen and the future of hydrogen impact all things geoeconomics and how we think about our economic model going forward. So lots of work being done there. Stay tuned, and thank you very much for your time. Enjoy the week. Thank you, everybody.
Thank you, bye.